Alright, let's look at the memo for the algebra part. Just close that. Okay, so here we have, okay, so this is stage 8 memo. Let me just change that. So for stage 8. Okay, so first up we have simplify the following. Okay, so here we have some numbers and letters, some algebra things. So first we have to see if we can add and subtract them, what has to be true? It has to have the same letters with the same exponents. If that's the case, then each term is a like term. If the terms are like, we can add them. So we see here we've got a p and a q, both to the power 1. Here we've got a p and a q as well, both to the power 1. Here we have a p and a q as well, both to the power 1. So these are all like terms. And as you can see, here we have pq, pq, and then qp. The order doesn't matter, right? Because if we have something like, let's say 2 times 3, that's exactly the same as 3 times 2. So p times q is exactly the same as q times p. So the order does not matter. Okay, all that matters is if it's the same letters with the same exponents. Okay, so let's start this. So all of them are like terms, which means we can add and subtract them. So we've got 17 of these things minus 13 of those things. So that gives us 4 of these things. Plus another 4 of them gives us 8 of them. So here we have 8 PQ. Now you can write it as PQ or QP. That doesn't matter. That's the same thing. All right. Next up, something similar. Now let's see again which terms are like terms. So I'm just going to color them if they're like terms. So we've got a t to the power 3 and a k. And we don't have another 3t to the power 3 and a k. So this is by itself. So that one's by itself, so we can just rewrite that one. So 13t to the power 3k. Then we have a t and a k to the power 3. We've got another t and a k to the power 3. So these are like terms. So they can be added together. Okay, so we've got negative 4 of these things plus 17 of these things. So negative 4 plus 17 is 13. So positive 13 of those things, tk to the power 3. All right, good. Next up, we've got another thing with lots of letters. So let's see which are like terms. So NLPW, NLPW, so these are the same. NLPW, that's the same. This one is not the same. So these first 3, these are like terms. They've got the same letters with the same exponents. So those are like terms. So let's add them. So we've got 2 of them plus 5 of them, which is 7 of them, minus 2 of them is 5 of them. So here we've got 5 NLPWs. Okay, plus this one just stays like it is, 3PWXL. And again, you can swap around the letters, that doesn't matter. And that's it. So you see, like terms is actually pretty easy. You just check which things have exactly the same letters with the same exponents, and the order doesn't matter. Then those things you can add and subtract. Then they are like terms. Question 2. Solve for x in each of the following. Okay, so we want to get x by itself. Now to get x by itself, what do we need to get rid of on the left? We need to get rid of x plus 11. We need to get rid of the plus 11. So what we can do is we can say, to get rid of the plus 11, we minus 11 on both sides. Because here, if we minus 11 here, then that cancels out, right? That's the whole reason why we minus it. And if we minus it here as well. So then we've got x equals negative 13 minus 11 is negative 24. And that's it. So as soon as x is by itself, and this is simplified, that's that. Okay, so you'll get a mark here for showing that to get rid of plus 11, we do minus 11, and then for the calculation for your answer. Next up, we've got 5x equals 30. So 5x means 5 times x. Now the opposite of times x is times 5 is divided by 5. So we need to get rid of the times 5, which means we'll divide by 5. So we're going to say x is equal to 30 divided by 5. And then we're going to say that means x is equal to 6. So again, first mark is for knowing that we have to divide to get rid of a times, and then for the calculation. And that's it. Next up, 3x minus 17 equals 16. Okay, so again, now we have to get rid of two things. We have to get rid of the minus 17 and the times 3. So let's first do the opposite of minus 17. So opposite of minus 17 would be plus 17. And then we can calculate that. That gives us 3x equals 16 plus 17 is 33. And then for the next step, now we have to get rid of the times 3. So opposite of times 3 is divided by 3, which means x equals 33 divided by 3, and then we just do that calculation. So 33 divided by 3 is 11. Oops, 11. All right. And now, so that again, you'll get a mark for knowing you have to get rid of the minus 17 to do plus 17, and for the times 3 to do divided by 3, and then for that. So in this case, it's just 2 marks. So one we've already seen in previously how to get rid of the times and of the minus. So you'll get 1 mark just for knowing to do the opposite, and then 1 mark for the final answer for the calculation. Question D. Okay, so now we've got multiple x's. So what we want to do is we want to group all the terms that include an x together. So I'm going to group all the x's on the left-hand side. So we have to get rid of the x's on the right-hand side. So at the moment we've got 8 plus 2x. So the opposite of plus 2x is minus 2x. So I'm going to minus 2x from both sides. So minus 2x. And on the right, if we minus 2x here, we're just left with 8, right? So basically, you can think about this plus 2x going across and becoming a minus 2x. That's the idea. So all we did was basically just said minus 2x, and then the 2x and the minus 2x cancel out on the right. Okay, so now we also want to get rid of the minus 19. So we only want x's on the left. So then we're going to say plus 19 on both sides. So if we add 19 to both sides, what do we have? Then we've got 5x minus 2x, and then the minus 19 plus 19 will cancel out, which is why we do plus 19. And on the other side, we'll have 8 plus 19. Good. Now we can simplify a little bit. So if we've got 5x's, and we minus 2x's, what's left is 3x's. And on the right-hand side, we've got 8 plus 19, which is 27. Okay, and then almost lastly, now we've got 3 times x, or x times 3. So opposite of times 3 is divide by 3. So we divide by 3 on both sides. And then finally, we just work out what that is. So 27 divided by 3 is 9. And that's our answer. Good. Number E. So again, we've got multiple x's, we've got brackets, we've got division, multiply, lots of things going on here. So first thing I would do is I would get rid of the fraction. So opposite of divide by 3 is times 3. So I'm first going to times by 3. So if we times this by 3, the 3's will cancel out, and we're just left with 4x on the left. And on the right, now we have to times this whole thing by 3. So if we've got 2 times something, and we times that by 3, we'll get 6 times something, because 2 times 3 is 6. So we've got 6, x minus 2. Now, again, many options we can do. I would say let's multiply the 6 into the bracket. So then we have 4x equals, and 6 times x is 6x. 6 times negative 2 is negative 12. Okay, now again, we want all the terms that include an x to be on one side. So I'm going to again take them to the left, but you can do it on the right as well, it doesn't matter. Okay, so on the left, I'm going to keep that 4x. But now to get rid of the 6x on the right, at the moment it's a negative 12 plus 6x, is a positive, right? If there's nothing written in front, it's a positive. So opposite of plus 6x is minus 6x. So we'll take it away from the right by minus. Sorry. And on the right, all that's left, if we take the 6x away, is the minus 12. And now we can simplify. 4x minus 6x is negative 2x equals negative 12. Now the opposite of times by negative 2 is divide by negative 2. So now we'll divide by negative 2. So x equals negative 12 divided by negative 2. And now we just have to do the division. Negative divided by negative is going to be a positive, and 12 divided by 2 is 6. And that's our answer. Okay, next up we've got question 3. So if it takes 12 people 6 hours to paint a house, and it takes 4 people 18 hours to paint a house, how long will it take 9 people to paint a house? Okay, so for this, we can see it's a proportion question. It has to do with the people and hours, proportion of people to hours. And we have to use a little bit of logic here to say that obviously if people are painting a house, the more people there are, the less time it'll take to paint the whole house. The less people there are, the more hours it'll take. So there's many ways we can do this, but the method we've been looking at so far is basically setting up a table kind of thing for this. So this is an indirect proportion because as the number of people goes up, the number of hours goes down. So let's say we've got people and we've got hours. Okay, and now let me see if I can insert. Let me insert something like this. Okay, and let's also insert some lines. I suppose it doesn't matter how well I draw the lines. Let me just do one more biggish line down here. Oops. Okay, it doesn't matter. Okay, so if it takes 12 people 6 hours, and it takes 4 people 18 hours, then how long will it take 9 people? So this is the part we want to figure out. Okay, so when it's an indirect proportion, so here we can see it's 12 divided by 3 to get to 4, then it means it has to be 6 times 3. Right, so times 3 if that was divided by 3. So that's what indirect proportion is. As the one goes down, the other one goes up. Or as the one goes up, the other one goes down. That's the idea. But there's an even easier way to check how this works in indirect proportion. So what we can see is that each column, if we set it up like this, has to have the same product. So 12 times 6, product means times, right? So 12 times 6 is 72. And then all of these will have a product of 72. So 4 times 18 is also 72. And then 9 times what will give us 72? That's right, 9 times 8. Exactly. Right, so that's a bit easier. Otherwise, we could have seen, okay, 4 times what will give us 9? 4 is going to be times 2.25, and then we can do 18 divided by 2.25. We could also do that. But again, that's more difficult numbers. It's not as easy to see what we have to multiply or divide by in this case. But basically, if it's indirect proportion, so if one goes up and the other one goes down, then the product of the columns is constant. So each of them have to product to the same value. Okay, so that's the easiest way to do it, I think, at least for now at this level. I can also show you what it would be like a little bit later on. We can learn a formula for indirect proportion would be the two things that are related, so in this case people and hours. So we could say people is indirectly proportional to hours. So we'll write this formula. And then we can use the first value we get given. So 12 people, for 12 people, it takes 6 hours. And then we can say, okay, let's solve for k. So times by 6 to get k by itself. 12 times 6 is 72. So that is k. Now, in our formula, we know that k is 72. Not k, h. So people equals 72 divided by number of hours. So we'll set up this formula. And now they ask us how long will it take 9 people? So then the people is 9, and we have to figure out what the h is. So to get h by itself, we'll times both sides by h to get the fraction away. So 9 times h equals 72, and then we'll divide by 9 on both sides. To cancel out the 9's, and then we get h equals 72 divided by 9, 8. So this will be very useful in the future, but for now, if you understand this table, how this table setup works, that's going to be easier for you, I believe. Question 4. Okay, write an expression for the following. 5 more than p. Okay, so we have p, but we have 5 more than that, so we add 5. And that's it. That's an expression. 7 less than the product of q and r. So 7 less than something means we take something and we subtract 7 from it. So 7 less than something. It's not 7 minus something, it's 7 less than something. There's a difference. Okay, the product of Q and R, product means times. So product of Q and R means Q times R. So Q times R minus 7. 7 less than QR. I hope that makes sense. Question C, the difference, okay, difference is minus. So we've got the difference between what? Difference between the quotient of K and T, quotient means divide. So we're dividing K and T. So K and T are divided. So the quotient of K and T, difference between that and the product of M and R. Product means multiply M times R, so that. So it's the difference between the quotient of K and T and the product of M and R. Right, so you see it's actually quite straightforward once you know what everything means. And you can just build it step by step, just reading the words and build your expression from there. Question 5. Okay, given this big expression here, how many terms are there in the expression? Okay, so we know that expressions are separated traditionally by pluses and minuses, by addition and subtraction. But we have the caveat that brackets enclose an expression, enclose a term, so make one term. So usually, if there were no brackets, these would be two separate terms. But since there are brackets around, this is now one term. Okay, so we've got 1, 2, 3, 4 terms. Okay, 4 terms. Now, what is the coefficient of x to the power 4? So a coefficient, that's the thing that is multiplied by x to the power 4 in this case. So what is being multiplied by x to the power 4? Well, here's x to the power 4. What's being multiplied by it? This, right? Positive 3 over 2. So we've got positive 3 over 2 x to the power 4. So this is 3 over 2. And now x cubed, where is the x cubed? Over here. What's being multiplied by it? Well, it's this whole thing, right? That is being multiplied by x to the power 3. Negative 10y. Okay? Negative 10y. And what's being multiplied by y cubed? Where is y cubed? Here is y cubed. So what's being multiplied by that? It's this. Negative 13x. Negative 13x. Okay, so does that make sense? So it's everything written next to, which is multiplied by the thing we're looking for. So everything multiplied by y to the power 3 is the whole negative 13x. Negative 13x times x times y cubed, right? Okay, what is the constant? A constant is a term that does not include any variables. So we have 4 terms. So this term, there are variables, x, y, things. This term has a variable, x to the power 4. This term does not have a variable, so that term is the constant, negative 4. Because this term again does have variables. So negative 4, that is the constant. Okay, question 6. This is the last page, yeah. Question 6. The sum of 3 consecutive numbers is 72. Okay, what does consecutive mean? Consecutive means follows directly on each other. I should have probably said three consecutive integers or 3 consecutive natural numbers, although consecutive would imply that anyway, because it is the thing that comes next. Okay, but we won't go into that into too much detail. So consecutive means comes directly after. So 2 numbers that are consecutive could be like 4 and 5, right? Because 5 comes directly after 4, even though we get something like 4.01, 4.83. That's in between, but that doesn't count in this case. We're only working with natural numbers when we're talking about consecutive. Okay, so 3 consecutive numbers, and we've got the sum of them. So the first number, let's call that x. Now, what would come after x? Okay, let me ask you this. What would come after 4? It would be 5, right? And how do we get to 5? Well, we say it's 4 plus 1, right? You add 1 to get to the next place. So after x would be x plus 1. And after x plus 1 would be x plus 1 plus another one, so x plus 2. Right, so these are 3 consecutive numbers. Got a number, that number plus 1, and then that number plus another one. So the sum of those 3 numbers is 72. And now we just solve for x to find the three numbers. So x plus x plus x is 3x. And then 1 plus 2 is 3 equals 72. Now to get rid of plus 3, we minus 3. So 3x equals 72 minus 3. And that gives us 3x equals 69. Now, so here we have 3x equals 69. Now we need to get rid of the times 3. So we divide by 3, which cancels those out. That means we've got x equals 69 divided by 3, which is 23. Okay, but the question asks, give the three numbers. So x is 23, but that's just the first number. So the next number after 23 would be 23 plus 1, which is 24. And after that would be 25. So the three numbers are 23, 24, and 25. And we can easily check if that works by just adding them together. So let's do some addition the old way. So let's first add those ones. Oh, no, let's add all of them at the same time. Okay, so 3 plus 4 is 7. 7 plus 5 is 12. Carry the 1. 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 2 is 7. 72. Correct. Okay, question 7. The sum of two numbers is 21. Okay, so we don't know what the two numbers are. So let's call them x and y. So the sum of two numbers is 21. And their difference is 5. So the difference between those two numbers is 5. Now find the two numbers. Okay, so here we have two equations. We've got two variables, so we can solve them simultaneously. So I'm going to do them with the elimination method. So here, let's do this. I'm going to say let's subtract these equations from each other. So I'm going to subtract this. So x minus x is nothing. Y minus negative y. So minus minus makes a plus. So y plus y would be 2y. And then 21 minus 5 is 16. And then to get y by itself, we divide by 2. So y equals 16 divided by 2, which is 8. So there's our y value. Now to find the x, we can substitute this back into any one of these two equations. So I'm going to choose the top one. The top one says x plus y, but we already know that y is 8. So x plus y equals 21. And now the opposite of plus 8 is minus 8. So we just subtract 8 from both sides. And that'll give us x equals 21 minus 8 is 13. Okay, now let's see if that makes sense. We can check it again. So if we add the two numbers, 8 plus 13, yes, we do get 21. And then 13 minus 8, that is 5. Yes, so that does work. Okay, so that is the elimination method. There's also the substitution method, which you could have also tried. Let me actually, I'll do the substitution method as well. So for the substitution method, we'll start with the same equations. Let me just do it over here. We'll start with the x plus y equals 21, and the x minus y, equals 5. Okay, now for substitution, we need to get an x or a y by itself first. So I'm going to use this bottom one, but again, it doesn't matter. And I'm just going to say, let's get the x by itself. So x equals, and to get the y across, we have to add it to the other side. So plus y plus 5. Okay, so x equals y plus 5. And now we substitute this into the other equation. So our other equation is x plus y, but we know that x is y plus 5. So x plus y equals 21. Right? But instead of x, we're going to put y plus 5 because x is equal to y plus 5. So y plus 5. And then we just solve. So y plus y is 2y plus 5 equals 21. Then we can say 2y equals 21 minus 5, which is 16. And that gives us y equals 16 divided by 2, which is 8. So y is 8. And then we can substitute that back into any one of the three equations we have now. I'm going to use this one. So x equals y, but y we already know is 8, plus 5. And that's going to give us x equals 13. So we see we get the same answers as what we got over there. So the red one here was the elimination method. The green one here was the substitution method. Okay, last question. split into 4 parts, A, B, C, and D. Okay, so we are told here the third term of an arithmetic sequence is 13. Okay, so arithmetic sequence, we know this is the formula, right? A plus n minus 1 times D. That's the sequence that's an arithmetic sequence. So Tn is the value of the term, n is the number of the term. So term 3 is equal to 13. Right, so term 3 is 13. I'm going to write this down here as my first calculation for A. So 13 is the third term. So it means n equals 3, right? So A plus 3 minus 1 times D. So let's just simplify that a bit. 13 equals A plus 3 minus 1 is 2. So A plus 2D. Okay, so there's one equation. Then we can also say the seventh term is 33. So 33 equals the seventh term. So A plus 7 minus 1 times D. And that gives us 33 equals A plus 6D. So now we see we've got two equations, two variables, so again we can solve simultaneously. So I'm going to write them underneath each other and say A plus 6D equals 33, and then A plus 2D equals 13. And then I'm going to subtract them. So the elimination method, A minus A is nothing, so we eliminated the A. And then 6D minus 2D is 4D. 33 minus 13 is 20. And then divide by 4 on both sides to get D equals 5. So now we have the value for D. Okay, so that's the question A, the common difference. Now the first term is A, right? So this is first term. Let me just write that in for those of you who might have forgotten. And D, that's our common difference. The thing we keep on adding each time. The common difference. Okay, so the first term, that's question A. That's A that we need to find. First term, that's the next thing we need to find, the value of A in our equation. So let's substitute. So we can choose any formula, any equation. I'm going to use this one. So I'm going to say A plus 2D, but D is 5, we already calculated that, equals 13. So I just use this equation here. Right, A plus 2 times D, but D is 5 equals that. So that gives us A plus 10 equals 13. And then we just minus 10 from both sides to get A equals 13 minus 10, which is 3. So that is A. So here's question A, question B, and then question C, the nth term. So now let's put them all back into our formula. So A, we found is 3. So A plus n minus 1 for the nth term times the common difference, D, which is 5. And let's just simplify. So that gives us 3 plus 5n minus 5, because we just multiplied the 5 with the n and then the 5 with the negative 1 to get this. And again, we can simplify, so 5n, and then 3 minus 5 is negative 2. So our nth term is 5n minus 2. And that was question C. And then finally, question D, the 123rd term. Now we can just use our answer that we had in C. So term 123 equals 5n, but n is 123 minus 2. So 5 times 100 is 500, 5 times 20 is 100, so that gives us 600, and 5 times 3 is 15. So 615 minus 2, that gives us 612. So that is the 123rd term is equal to 612. Okay, I would say these last two questions, they would rate this a little bit more complicated. So they would rate as hard questions. So if you found them a little bit difficult for now, that's fine. They're supposed to be a little bit hard at the moment. Next year, you'll find this very easy, but for now it's quite new. So it's fine if you found this a little bit difficult to know what to do. No problem. And question 6 as well, maybe. 3 consecutive numbers. These ones, question 5, I think this you should know. Question 4, writing expressions. That's also something we practiced a lot. This one, solving for x, very important. Make sure you do lots of practice questions on getting x by itself. Okay, adding and subtracting like terms. I think once you get it, then you get it. Then you can never unlearn this. But in the beginning, it might be a bit confusing to understand exactly when things are like terms. But once you get it, you get it. Then you'll see. Then you won't remember why you ever struggled with something like that. But okay, I'll go through it, and yeah, let me know if you've got any questions or if I made any mistakes along the way. That can also happen. If you think there's a mistake in the memo, please let me know. All right, I hope that was helpful.